Alright, we are still in Chapter 3. We're in Unit 1, and we're continuing to go through some practice problems here. Again, the practice problems, there's just one problem after another. Make sure you pause these, copy some of this down, try to get your pictures as best as you possibly can so you can get these answers. But basically what this is saying is you got a research center for people and press, and it asked representative samples of U.S. adults about global warming. Repeating the question over time. In January 2007, the responses reflected an increased belief that global warming is real and due to human activity. All right, here's a display of the percentages of respondents choosing each of the major alternatives. So, 41% feel that it was due to human activity. 21% due to natural patterns. They're saying there's no evidence. 20% don't know. All right, so we got it all there. And as you're looking, just roughly, that's roughly 40, roughly 20, 60, 70, 80, 90, right? So I'm looking at around like 92. So the problem is, as I'm looking around here, do you notice it seemed to add up to all of them? So perhaps the most obvious error that I see in this, like if I was to list an error as the problem asks, is that the percentages, it's roughly 92%. It's not even 100%. So where's that other little area of that? And the three-dimension part of this, it distorts the regions of the graph. Like I can't really tell. Like, is this piece bigger than this? Is it not? Like I think this piece is bigger, but it kind of distorts the images. So the region corresponding to no solid evidence, this one, and this one, this definitely looks bigger to me, right? So the angles kind of contort what it is, right? So easier to view with just a simple 2D graph, and then on top of that, it doesn't even add up to 92%. But these are the things that when people look at this stuff quick, people can morph data with pictures, especially, to make things look how they want. If I didn't point any of this stuff out, you'd be looking at this saying, oh yeah, it makes sense. It looks like most of the people view that. It's like, well, they do, but not everyone. A majority of people believe something different than it's by human. If you add all those up, but it's hard to see, right? A survey of athletic trainers, right? And here's where it's coming from. Asked what modalities, which are basically treatment methods, such as ice, right? Using a whirlpool, things like that, ultrasounds, they commonly use to treat injuries. Respondents were each asked to list 3 of them, and the article included the following figures. So here is percents of each one, right? So it says, what problems do you see with the graph, and consider the percentages for the named modalities. Do you see anything odd about them? So 30, 40, 52, that takes us up to 60, 70, 85, 95. So, I mean, when you're scanning through these, like, it doesn't look too far off, like, quick view that I'm saying, right? 0, 5, 10, 15, 20, 25, 30, like, that seems, pretty good. So far, those don't seem too different, but when you're scanning these, it says the bar, right? Looking back and seeing the depth, all right, it can be very misleading, and I'm sorry if that's in the picture, but it says the bar chart of those bars should have space between them. This is kind of, because they're touching, look like a histogram. So normally when you do a bar graph, the width and the depth of these is very misleading as to what it is. So this is more of what a histogram would be. You'd want spacing in between them. And running the labels on the bars from top to bottom like this, could also be confusing. They normally just kind of label things sideways so you can read them. You don't want to keep twisting your head. And look at that. It's twisted the other way. I'm twisting my head that way, and I'm twisting my head this way. So I'm giving you concepts of how they would like to see graphs is basically what I'm doing. All right. So considering the modalities right there, do you see anything odd with it, right? Well, the percentages sum to 100%. Normally, we would take this as a sign that all the observations have been correctly accounted for, right? Because it adds up to 100. But in this case, it is extremely unlikely. Each of the respondents was listed. There are 3 ones, and they came up with this. So, for example, it will be possible for 80% of the respondents to say they use ice to treat an injury and 75% to use that. The fact that these add up to 100, right? Remember, they had 3 different responses. These could be much higher than that. You would think most people, when they were taking it, would just say, yeah, ice. They use ice. You're saying only 30% of anyone responded ice, and they listed 3 different things. Each person listed 3 different modes of getting help, and you're saying that only 30% of the people total did that. There should be a multitude of different things all over the place. I know they have other, but if these are the big things you're telling me, like the other, I feel like there'd be more categories, right? The fact that the percentages total greater than 100 is not odd. In fact, in this case, it seems wrong that the percentages do add up to 100. All right, hopefully that kind of makes sense what I'm implying here by this. Like, how is that even possible? Right? There should be, these percentages of each should be all over the place. They shouldn't add to 100, right? I would assume, like it says here, ice, 80% say they get ice. Lots of times when people trip and fall, they get ice, so it doesn't swell up. That should be higher than 30%. This seems odd, right? Teen smokers. You got an organization monitoring the future, asked in 2048 8th graders who said they smoked cigarettes, all right, and what brands they preferred. So the organization monitor asked 2,048 8th graders, I should say. Wow, okay. The table below shows brand preferences for 2 regions of the country. Write a few sentences describing the similarities and differences in brand preferences among them. So, as we're reading this, right, we want to set our stuff up. It says, according to the teen smokers, according to the monitors of the future test, teen smoking brand preferences differ somewhat by region, right? All right. The South and the West, it's about the same. They like the Marlboro, but as you can see, drastic different in Newports, pretty different of Camels and other brands, but they're pretty similar on those other 20 brands, I guess. But the Marlboro, they're also pretty similar. But it says, although Marlboro is the most popular brand in each region, with about 58% of teen smokers preferring this brand in each region, teen smokers from the South prefer Newports in a higher percentage, right? 22% to approximately 10. Camels are more preferred in the West as well, all right, with 9.5% of teens smoking preferring this brand, especially to the only 3.3%. Okay, teen smokers in the West are also more likely to have to particular brand that needs smokers in the South. So this is saying that there might be other brands in the West that the teen smokers in the South don't use. Both regions have about 9%. All this is just, can you look at data and can you decipher and write down a paragraph about what you see? And it's all obvious stuff. Nothing that was written down here is out of the ordinary when they want you to just describe what you see, okay? Describe what you notice in the graph. Seniors. Prior to graduation, a high school class was surveyed about its plans. The following table displays the results for the white and minority students. All right, so white versus minority students. What percent of seniors are white? Well, these are all seniors. All of them. Okay, so the point is that they're all seniors. There are a total of 268 white graduates and 325 total. So of the graduates that are white, 82.5% of them are white. All right, do you follow how I got that? So I took the table and basically I found the totals of the frequencies and the margins, okay, is what's happening here. So I totaled it the whole way down. That's why I'm getting my 325 here. Okay. So taking a look at our table. All right. Part B, if I scroll back, says what percent of the seniors are planning to attend a 2-year college? All right, a 2-year college. Now, this is what percent of seniors. That means all of them. All right. So as we look at this, there are 42 total seniors planning to attend, but out of the total, right? So 2 years, 42 out of the total right there. Part C, it was asking for what percent of the seniors are white and planning on attending a 2-year college, right? White and planning a 2-year college. So that takes us back to this one. 36 were white, but out of planning a 2-year college, out of the 325 total, they are white and doing a 2-year college. Those are the only ones that overlap. And the key word there is and, when they want both, right? What percentage of the seniors are white and planning? That's basically saying where they overlap, and that's where they overlap out of the total. What percent of the white seniors are planning to attend a 2-year college? So, what percent of white seniors, all right, are planning to attend a 2-year? So now they gave you a new total. I just want to know out of the white seniors. That's all they're asking. So out of the white seniors, there are 268, and 36 are going to that school. That's basically what we're saying here. And then part E, sorry, I have to keep scrolling back to see them. What percent of the seniors planning to attend a 2-year college are white? So they're telling you the total. 2-year college are white. Okay, so with that one, there are 42 graduates planning to attend a 2-year college, and 36 are white for that percent right there. Okay, so it's understanding how to do frequency tables is basically what we're looking at. Look again at the table of post-graduation plans for the senior class we just did, and find the conditional distribution, the percentages of plans for the white students. All right, so conditional plans for the white students. So, for white students, 73.9% plan to attend 4-year college. All right. 73.9%. 34.4% plan to attend a 2-year. 13.4% plan to attend a 2-year. 1.5% plan on attending, going to military. 5.2% will be unemployed, and 6 are other when it's all said and done. Now, I know you look at those and you want to know how. How are they getting that? Well, look back at the question again. Find the conditional distribution of plans for white students. We just want to know the plans for white students. So if I just want to know the plans for the white students, then I take the 198 divided by 268, 36 divided by 268, 4 divided by 268, 14 divided by 268, 16 divided by 268, and that's where all of those plans are coming. Conditional, meaning I don't want the total, I just want what happens there. Part B says, find the conditional distribution of plans for the minority students. So minority down the side, well, minority there, 77, 10%, and so on. So if you want to pause the video so you can see with each of those where they are coming from. And then it says create a graph comparing the plans of white and minority students, and do you see any important differences? So let's now take a look at a graph of them. All right, so I just have white students versus minority students with the segmented graph. And right here, they look pretty similar. They look pretty similar there as well, as we're trying to add this all up. Like, there's nothing that seems necessarily too far off as you look at that graph, right? Looking at each of them as a whole, comparing the white and minority students, right? But taking a look there, all right, let's see what we have. The conditional distribution of plans for white students and minorities are similar, right? 74% for 4-year versus 77%, 13 for 2-year versus 11. Both military is 2 for both, 5. They're pretty close. Each graduate is almost 2%, right? Still, the conditional distributions of plans are essentially the same for both groups. There's little evidence of association between race and plans for graduation. Everything seems to be about the same. And we will stop there and come back with this next example.